Hello and welcome to Anglo-Irish Astro. And the first thing I'm going to say, and I have been practicing this, so please bear with me. Sai hei bok man hei bandao sai, and in Chinese, Gong Zai Fai Chai, or Happy New Lunar Year. And it's kind of interesting that our February show is actually right on top of Chinese Lunar New Year. So without any further deviation or repetition, we'll get started. So my name's Nick Yvette. Ladies.
I'm Susan McKeon from Dublin, Ireland.
I'm Anne Dunn from Astronomy Ireland.
And chaps.
I'm Neil Norman.
And Johnny Horn, Head of Science at Hadley High School.
Welcome to the show, Johnny.
Thank you.
And do you want to kick off with what's on view?
Yeah, I think last time we stopped at Friday, February the 19th. So I'm just going to carry on from there. So the quarter moon will be between Pleiades and Hyades all night with Mars just below it. So that's going to be an amazing sight, like really close together. Then on the following Wednesday, February the 24th at 11 p.m., the moon will be almost full. And it'll be just 2 degrees below the Beehive cluster. So that's going to be like amazing. So if you have a look with binoculars, it's going to be something really worth looking at. Then Sunday, February the 28th, and right through March, actually, until about March the 15th, have a look at Mars because it's passing underneath the Pleiades again. A lovely sight to behold with binoculars. The closest they'll be, Mars and the Pleiades, will be on March the 4th. But you have 3 weeks to have a look, and you'll be able to see them both in binoculars at the one time. And it's also a great opportunity for astrophotography enthusiasts. So then there's not much going on planet-wise, really. So it's a good time to try and spot more deep sky objects apart from the obvious Orion constellation with its twinkling dog star Sirius. Why not try and find the Andromeda Galaxy, maybe, which is our nearest neighbour. And of course, there's always the moon in all its phases. It's always beautiful with binoculars or telescope. And that's about it, really. The planets are a bit in hiding at the moment. So it's more deep sky objects and the moon.
Yeah, one thing I'm going to say about looking at the Beehive cluster and the moon is start with the Beehive cluster first, because the moon is almost full. But when you look at it, it's going to blind you. If you go to the moon first, you won't see the Beehive cluster very well afterwards. The other thing, of course, is regards to looking for Andromeda. Most people can actually see it with the naked eye. You do need to be in a very dark sky area, and good vision does help. I have actually done it. I did it quite a few years ago in upstate New York, on the edge of a state park, quite near to where I was living in Cohoes, New York. But it can be done. But you really do need dark sky. So, anyway, Apophis. Apophis is back. When isn't it back? It's gonna fly by us safely on about March the 5th. It was discovered really back in 2004, and it will pass by over 40 times the distance of the moon from us. That's 150 million kilometers. It is due back in 2029, where it'll be a lot closer. However, in the meantime, scientists are hoping to study the flyby a bit more closely so we can find out even more about it. Current belief is peanut-shaped. It's made of rock and metal. It's about 300 meters wide, which is about 3 times the height of the spire in Dublin, or about half the height of the cliffs of Moher. In comparison, Skellig Michael is 218 meters.
About the size of 3 football pitches. Nobody knows the spire.
In the Egyptian mythology, it was a demon who caused chaos whenever it was around. And I have to say, whenever I hear the name, I don't think quite that way. I always think of a guy with glowing eyes on Stargate SG-1. Just habit, I guess.
Yes.
But anyway, it's 300 times more massive than the Tunga-Niska, which we now think is maybe a comet, which became an airburster, and that flattened about 80 million trees in Siberia back in 1908. And it's 5,000 times more than the more recent Chelyabinsk airburster in Russia back in 2013, which was only about 20 meters, yet it injured almost 1,500 people and caused damage to 7,200 buildings.
We know why the people got injured, because they saw this massive smoke train across the sky and they all looked out the windows.
Oh, yeah, they were too close to the windows.
And window smashed.
It was the glass, yeah.
Yeah, that was just it. The majority of the injuries were from flying glass.
Yeah.
In order to study Apophis again when it comes by, the scientists will yet again use radar. Now, obviously, with the loss of Arecibo, they'll now have to use 2 radio telescopes instead. One is part of NASA's Goldstone Deep Space Communications Complex in California, and the other one will be, of course, the Green Bank Telescope in West Virginia. So at the moment, the April 13th, 2029 flyby will be the one for the record books. On that date, Apophis will be become the closest flyby of an asteroid of its size, when it comes no closer than 31,300 kilometers above the Earth's surface. When you think about it, the Earth's gravity will actually move boulders around on the object or even stretch it, but that already does depend on its constituents.
Yeah.
There is a graphic which I will put onto the show notes, and the distance between Apophis and the Earth at the time of the asteroid's closest approach. The blue dots are the many man-made satellites that orbit the Earth in the Clark Belt, and the pink dot obviously represents the ISS. So that would be there as well. It's going to be interesting. We're going to learn more about it, but I'm going to stress this straight away. Apophis is not going to hit us. At best, it may actually get slung out and start a long, lonely trek into the solar system, well away from us. But as I say, it's going to come back a few times. We've already lost a mini-moon, which also turned out to be a Centauri rocket stage. So it's all fun and games in Earth orbit, as they say.
Mm-hmm. And of course, the impact from something the size of Apophis would have the equivalent of, like, I think it's 1,200 megatons of TNT. I mean, I think Tunguska and the meteor crate were only between 3 and 10 megatons, weren't they? By comparison, I think.
Well, it will be quite an event. We don't think it would be as bad as the Chicxulub impact, which actually
no way.
Which caused the KT boundary on the Earth.
Yeah,
a very thin layer of iridium, and of course it won't put as much. It won't possibly do as much damage. We're a bit more with it. We have a space program, unlike the dinosaurs that didn't. So perhaps we have a better chance of surviving.
Well, maybe.
We do have Johnny Horn with us, who is actually a real school teacher.
Yes.
And he's involved in astronomy in schools, and he's going to tell us all about that, aren't you, Johnny?
I'll try. I was just wondering, actually, just talking about the impacts of various different things as you were talking there. I've always thought noticed that the convention seems to be to talk about them in terms of the multiples of the nuclear weapon that went off at Hiroshima. Mm-hmm. That always seems to be a thing that the media tend to do. Yeah. Why is that? Do you know?
I think because it's the only thing that really can compare with the impact of something like Apophis on the Earth's surface.
Yeah.
An atomic weapon's ability to devastate is referred to against trinitral-toluene, TNT. So the original marker was good old-fashioned TNT. So now it's megatons of TNT, and we've applied that to not only to nuclear weapons, but to natural weapons of disaster, of mass destruction, like asteroids and comet heads.
There's a couple of interesting programs that you can find on the internet where you can define the size of this of a particular object, its constituency, and the effect that it would have if it hit Earth at various different speeds, times, places. And that's always something that kids find quite interesting, just the absolute destruction that one of these things could do to us and the way of life that we have.
I was going to say, get the kids to watch like a program where the Russians dropped the Tsar bomb, the biggest nuclear weapon ever detonated in our atmosphere. And then, as you say, I mean, that was only 57 megatons. And as I say, Apophis would hit us with 1,200 megatons. So the kids can sort of like time that by, get their abacuses out and calculators and just think what one of these things could do.
Yeah, absolutely. And it's interesting because that gives the idea of scale, doesn't it?
Yeah.
And scale is one of these things that all the way from primary school, through high school, that we try and do with pupils, give them an idea of the scales of the universe. Because the day-to-day lives that we have it's almost impossible to imagine quite how big and how far away and how fast and how strong and how much of an explosion these things do. And so, I've done exactly that, shown them the Sarah bomb, and asked them to compare it to some of the other things that give off energy inside our universe. So that's definitely one of the ways that we can do it. Scale of the universe, though, is one of the things that I love talking to them about. It's always the first thing that I talk about whenever we start to talk about what's out there, and giving them an idea of the numbers that you have in space. What does 100 billion stars look like? Because that sort of number is just inconceivable to the teenage mind. I mean, it's inconceivable to most human minds, isn't it? And one of the useful things that I found of doing that actually was a fantastic high-res photo that was taken of our Milky Way galaxy. And you can stick it up on the whiteboard, and you can zoom in on this thing, and you can keep zooming in, and you can keep zooming in, and you can keep zooming in. And only after about 15 levels of zoom do you actually start to see the individual stars that make up our Milky Way. And you can zoom in until you are, effectively seeing on an entire screen 1 pixel of the original image of the Milky Way. And this 1 pixel is just absolutely rammed with stars. And you can set them the task of trying to count them and then stop them after about 15 seconds, because it's an absolute waste of time to give them this idea of just really, truly how many stars there are purely in our galaxy. And therefore, how many galaxies are out there in the universe, and it blows their little minds. So it does.
If you want a really good comic way to do this, is to go to Monty Python and the Galaxy Song.
Oh, that's a starter.
Oh yeah, yeah.
That's a guaranteed starter, an absolutely brilliant one. And I never stop myself singing along with it, because I learnt it from The Meaning of Life when I originally saw it, and I just thought it was an absolutely brilliant thing. And then to find out how accurate it is as well, it's really good.
Yeah.
There's 2 videos that go with it, and the actual Monty Python one, I think, is the best, because they've not only have they got Stephen Hawking, they've got Brian Cox. Brian Cox getting well and truly beaten up by Professor Stephen Hawking in his chair. I think that's probably the best part about it. But I know that Anne and Susan remember it, because I shared it with them a while back, a few weeks back, on Facebook. But I've always loved that. I think that's the best part. And of course, right at the end, his chair becomes a spacecraft, and he zooms off at warp speed.
Yeah,
Fantastic.
Something similar in Simpsons with Professor Hawking as well. It was just anything with him. It's just funny, and I think it also would help a lot kids just to look and be interested when they see it more from the funny side rather than the analytical, interesting, maybe boring side. I've
got some of his books for the general public, and they're brilliant. When I got to the point where, okay, this is fine, but this doesn't really tell me anything, I had to switch over to Leonard Susskind's books, because I wanted the math. I got hungry for the maths. And his holographic universe book is really basically a book of mathematics in which he describes the holographic universe.
Light reading.
Yeah, I suppose it is really. It's something I've always grown up with. If I want to find out, I'll go and find a book by one of the specialists. I started off with Kip Thorne. Kip's a great guy. He can explain anything with very little mathematics.
Good.
Then you get on to Professor Alex Fiponenko's stuff.
Oh, yeah.
And there's some mathematics. Then the mathematics start coming in, and then because you're so wanting the juicy stuff, if you want, then you start buying the guys who are writing most of their book in mathematics, and you're sitting there at work at lunch, and you're reading this book. And all you get doing is, oh, didn't see that coming. And everybody's looking at you as, what the hell are you reading? And then they come over and they take the book off you, and then they look at the cover and look in what you're reading, and it's a page of mathematics.
A good one for the kids to start off with, maybe that book, Turn Left at Orion, for Sky Spot.
Yes.
Yep, that would be a good book.
That is.
If you can get a hold of stuff by Dr. Phil Harrington, Now, he teaches astronomy in the States at Stony Brook College in New York. And his books are for kids to get into. They are brilliant because he a lot of stuff he does, he starts easy and then he progresses you onwards. And I say I've done shows with him before back in the day when SLU had a radio station. Some of us got co-opted because we were so good at what we were doing at the time. We ended up chucking stuff into the show. And it would be a case of we would successfully divert the speaker into going into what we were talking about in the chat room, which is quite often cannibal dwarf galaxies, aka Centralis A.
That would totally interest children, cannibal galaxies.
Yeah.
I mean, straight away, the kids would be like, cannibal what? You know?
Exactly. Keywords like that are so important. Yeah. And you know, being able to, just going back to the books that you were talking about, being able to scaffold things properly for children is so important. If you go in with some really high level math straight away, you're instantly going to alienate a whole load of kids from any subject that you try and do.
Oh yeah.
Regardless of how interesting you might personally sort of, you know, feel about it. But kids never find space boring. It is the one thing that absolutely every child in a classroom will just sit there and listen to or watch and have a million and one questions about. Because, you know, they all approach this thing with a schema in their minds. There's so many, you know, movies and things that they see that they don't know quite what's real and what's not, and they all have these ideas about what's out there, and they have so many questions that they want to ask you. And it's just, you can spend a lesson or two lessons just having this open-ended discourse with them before you actually have to try and go through some of the program of study, and it's a fantastically satisfying and interesting thing to do compared to some other parts of science where you do feel like you're dragging them through the national curriculum. This is one thing that students are really, really engaged with from the get-go.
A couple of years ago, I did some work at the local primary school here, and I had an after school club, astronomy club, and that was the one that was booked up. We had like 30 people, and the other clubs were having like 10 or 11, but everybody wanted to do astronomy. And I went into my daughter's class because they had a day when, you know, the parents would go in and talk about what they do. And I obviously went in and said about astronomy and stuff.
Cool.
But the worst thing was, one of the teachers, this is a primary school teacher, I hasten to add, not a high school one, as your good self, but the primary school teacher turned around and said to the class in front of me that, asked the children, which is the hottest planet in the solar system? The children threw a couple of answers out, and she turned around and said it was Mars. She turned around to me and said, "It's Mars, isn't it?" And I said, "Why? No." She said, "Well, it's got to be Mars because it's red, so obviously it's hot." And I didn't say it, but I thought, seriously, there's 26 children sitting on this mat, and you just told them that the hottest planet in the solar system is Mars, and you're a teacher. So seriously?
I'd love to tell you that was a rare experience. However, I'm afraid that it's just not, unfortunately. You know, primary school teachers, bless them, have such a hard job. They really do. Having to try and be, you know, as expert as they possibly can do in so many different areas, because they teach the whole thing, don't they? You know, they don't get the advantages of specialization at high school like we do, or the even further specialization at A level. And yeah, there are so many misconceptions that students come to us with from primary school, all across the spectrum in all subjects, but especially in science. You know, it's been studied and known that, unfortunately, the confidence of primary school teachers in teaching science is quite low, basically, and there's a fair bit of sort of money and time thrown at trying to improve that confidence and their knowledge base as well.
I do think it's down to just pure encouragement from even when them teachers are young. There was no encouragement to look into space or to learn, say back in the 80s or even in the 90s. It was, I used to go to my local library and read books in the library that I'd have to leave there because I only could bring 2 home. There wasn't a huge amount of access. So, and all you were reading as well was all just from people who are speculating that didn't know a huge amount, but they were trying their best. So a lot of it is down to pure lack of knowledge, but we don't have that anymore. We have the internet.
Yeah, and it was interesting, actually. I was talking to Neil when he first asked me to come on the show about our experiences as children, because we're of a similar sort of age. And I was thinking, actually, yeah, what did I learn in school about space? And I couldn't think of a single thing, actually. And I was like, well, where did I get all that knowledge from? And it was from family and friends, as an interested scientific type boy who were buying me books about space and getting encyclopedias and learning about all this sort of stuff. And that's where I got my knowledge from. It wasn't actually from the schooling that I had.
And of course, we had the Sky at Night. Patrick Moore and the Sky at Night was a must-see program.
Mm-hmm.
We had to watch that program. Well, I'll tell you what, Johnny, last year we had a naked eye comet, which doesn't come around very often. I think the last really good one was obviously Hale Bopp in '97, which obviously a lot of your students weren't even thought of then. But were you aware of it, and did you at all, or did you get the children out to see it if you were? Or
well, I got my own daughter out to see it. I certainly went out to see it as well, and told my classes to go out and see it. And it was something that I mentioned quite a bit. And it's normally down to the enthusiasm of individual teachers about these extra things outside of the curriculum to tell students to go and do, because students there's so many distractions, so many reasons to stay inside the house these days. There are so few kids who will just go outside and see the natural environment, and even less of them who'll go and do it in the middle of the night as well. Having that encouragement from a teacher is important. But the most important thing is having that encouragement from parents as well. It's the parents who encourage their children to get up, go out, and go and see these things. Go on walks in nature. Go and actually see the natural world around them, whatever that may be.
Absolutely.
See, one of the things I remember from school was that we had a few teachers who would dabble in it, and in my town, I'm in Bedford. We have Bedford School, which has its own observatory. So if you were at Bedford School, then you were lucky because the observatory was there. But the thing is, though, I think when I was growing up and I was going to school, we had quite decent science programs, and we had people, like James Burke, who could stand up, who could talk a mile a minute for up to an hour and give you fact after fact and link everything together, and tell you how you got from this to a space mission. It was called Connections. But he was one of the few people we had on the telly, apart from maybe the Tomorrow's World people, who could actually talk authoritatively on television. Yes, we had Patrick, and Patrick's greatest thing was he could keep it simple and not make you feel dumb.
Yes.
And that ability to explain is so important. I remember we took a few busloads of kids on an overnight trip to London about 5 or 6 years ago. There was a science thing that was going on, and one of the speakers was Brian Cox. And all the other speakers, did the usual thing in science shows, and they had kids up and they were doing experiments on stage, and it was all very whizzy-bangy. And Brian Cox stood up and he literally just talked for an hour and a half solidly. And the kids were absolutely loving it. They were so engaged with what his topic was.
I think one of the other things, of course, is I give Chris Lynn top marks because he has to remember that not all of us are either his students or his peers when it comes to astrophysics. But he keeps it. Him and Maggie. Aidan Peacock do manage to explain things, and I have to admit, I think one of the fun things about the Sky at Night now is Maggie gets so enthusiastic and starts bouncing around, and it's great because a lot of the time the kids can actually relate to somebody like that.
Yes,
who's enthusiastic and bouncy.
Just referring back to what we learn at school, and I don't know, probably depress you a little bit actually by reading you out from the DFE's Key Stage 4 guidance on the topic of space physics, okay? So I quote from the document itself. I quote from the document, the single line in space physics for the Key Stage 4 national curriculum, which is the main features of the solar system. That is all that children are expected to know in this country at Key Stage 4. Fortunately, exam boards and educators know that children enjoy this, and so we teach them a whole load more than we're expected to. Basically, there's and you can actually do an astronomy GCSE. Yep. It's one of the few GCSEs that escape the cull when the new GCSE system came around in 2016, 2017. And we had actually in our school run an astronomy GCSE 2 years before that. Because there were some very keen students. There were 3 or 4 keen students in school who were like, well, look, we really want to take this extra astronomy GCSE. And so the head put it on for them and spent her own time after school with these kids, helping them go through their astronomy GCSE. And one of them, his younger sister, is actually in my form at the moment. And I was asking her how he was getting on. And he actually is doing astrophysics at King's or UCL in London at the moment. So, it just goes to show that when you give students the opportunity and allow them to engage with their interests, then they can go on and take it at the highest levels.
Sky's the limit. That's wonderful to hear.
I have to admit, I've got a copy of the GCSE and astronomy syllabus. I have a copy of the course as well. I need to knock it down and get back onto it. And interestingly, interestingly enough, one of this was something that our dear friend Patrick Moore had a hand in to some degree when it was first came out, because one of the first teacher guides and student guides was written by Patrick Moore for the astronomy GCSE. Yeah,
fantastic.
Right now.
Can I depress you again then a little bit with how many children take the the astronomy GCSE or took the astronomy GCSE in this country in 2018? And the answer is the figures aren't available. Because so few did. It comes under other sciences, which would include environmental science and a couple of other smaller subjects as well. And that was less than 2,500 children in the entire year.
It's a shame, really, because with all the modern instruments, and ironically, this is part of the reason I'm actually technically back in school already, and I'm studying languages. I'm taking Korean and Japanese. Because at the moment, in the whole of the world, there's only 3 countries who are actually pushing the limits on new telescopes, both optical and radio. That's China, Japan, and South Korea. A lot of it, yes, we have the European Southern Observatory. So a lot of the work that's done in Japan and Korea ends up in the ESO. And the Chinese have actually stolen a lead. Well, I say that quite nicely, actually, because they've actually turned a complete valley into a radio telescope in China. And given the fact we have lost Arecibo, and there are potentially plans to bring it back, to rebuild it, refurbish it, and get it back online, because really it is a very important part, not just of the Deep Space Network. It is very much an essential part of NeoShield and Spacewatch. Now, for those of you who are wondering what that is, NeoShield and Spacewatch are concerned with near-Earth objects, things like our friend Apophis. They discover, track, and they actually have amateur astronomers throughout the world who image and add to the data, so the orbits of these objects can be refined constantly by the Minor Planets Office.
Minor Planet Center.
Yes, thank you. Originally, everything was done with pencil and paper. Brian Marsden was one of the greatest human calculators our planet had.
What?
He could rustle up a set of an orbit and give you an idea of when and where you could see one of a near-Earth object or a comet or an asteroid or a minor planet very, very quickly. He would take 4 or 5 observations for amateur astronomers and produce a prediction which could then be tested by astronomers and refine it as it went along. Now it's obviously all done by computers and n-body simulations, but still,
it was thanks to Brian Marsden that for example, comet Swift-Tuttle was everybody predicted to come back in 1982, and Brian Marsden got his pen and pencil out and did a bit more calculating from the old measurements and decided it was going to come back in 92. He was correct; the others were wrong. So he is a genius.
Yeah. And ironically, going back slightly to our explosions, thing is, he was part of the Shoemaker-Levy 9 thing, because basically that gave us, not only did it show us what a fragmenting comet could do to an atmosphere, in this case Jupiter's, the whole Shoemaker-Levy 9 story gave us an answer to an ancient riddle on Callisto and on our moon and here on the Earth. There was a chain on Callisto and the moon, there is a chain of craters where the impacts are such that there is a long chain, perfect chain. Now, we have discovered them on the Earth. They're pretty much eroded and gone, but they're still the evidence of their existence. And because of Shoemaker-Levy 9, we now knew what caused them. Nobody could figure out why there was this long chain of craters on Callisto until they actually tracked in all the fragments from Shoemaker-Levy 9 as it impacted Jupiter. And now we had the answer to a long-standing riddle.
Yeah.
But it took us being able to see this. In fact, it was so important that even though the Hubble had just had an update and it was still going through its testing, they actually forgot the whole test routine. To heck with that. We need it. And they tasked it to Shoemaker-Levy 9. And again later, when Anthony Weasley recorded his impactor on Jupiter. So and that alone showed us the importance of tracking these objects in regards to the Earth. Because now we know what's there, how many of them, where they orbit, we can start figuring out which one has our planet's name on it. And right at the moment, none of them do. But that can change.
No.
And one thing I will say is Jupiter is a very benign planet to a point. It vacuums up these comets, these bits of space rock, absorbs them. But then again, it has its evil side. And it can also kick stuff into the inner solar system. It does send comets in occasionally, and then they put on a beautiful show for us, and they head out. Sometimes never to be seen again, because their orbits have gone from a parabola to a hyperbolic orbit, which means they'll exit the solar system and will never be seen again.
Mm-hmm.
It's one of those things, and it just popped in my mind after what we were talking about earlier. And of course, it's captured one of those interstellar visitors. One of the centaurs that's held by Jupiter is now believed to actually be an interstellar visitor, like Borisov 1, Borisov's first comet, which came past us. Very, very fast detection. Very short detection because it suddenly appeared. And of course, we had the first interstellar visitor.
Oumuamua.
And of course, now we know possibly that one of the centaurs that Jupiter has captured is one of these objects. So we have potentially 3 in our solar system that we know about already. Anyway, back to the other things.
Am I right in thinking that that Jupiter had done some sort of rearranging of the solar system as well back in the day?
The interesting thing is, it's potentially possible that the solar system had a realignment in its early days, because for a gas giant to form, it has to be relatively close to the sun.
Mm-hmm.
It's understandable for a rocky terrestrial type planet to form further out in the solar system. There's more material available, whereas closer in, there is a lot more gas. So, but we still don't quite know what perturbed the solar system into ejecting the gas giants outwards and drawing the rockier planets in.
Mm-hmm.
Again, there's still a lot to learn, and this is probably the reason we need more missions like New Horizons. We need to go out to the Kuiper Belt. We need to look at some more of the trans-Neptunian objects, because they are literally frozen time capsules from the early solar system. And the thing people don't realize is our solar system actually extends almost well over halfway to the nearest star. Our solar system is actually that large. In order to actually leave the solar system, you have to actually enter another solar system. How's that for potatoes?
Yeah, when you tell kids things like that, and when you tell, because they've learned ever since primary school, my very easy method just speeds up naming planets. And when you tell them that actually this has not always been the case, when you change the schema that they have about things, they find that endlessly fascinating. That the night sky, the planets, the things that we have always taken as for granted have not always been that way and may not always been that way.
No, it's true. Yeah.
If you look at a lot of the exoplanets we're finding, the gas giants are close into the star, and the more Earth-like are further out.
Hot Jupiters are ridiculous in number, aren't they?
Hot Jupiters, yes. It seems to be that it's easier for a Jupiter-sized planet to form closer to its parent star than it is for a rocky planet. Now, obviously, when you look at one of these systems, you're looking into the past.
Yeah.
It's one-way time travel, folks. You're looking into the past.
Yeah.
So if you think about it, when you look at Andromeda, you're looking millions of years into the past.
Yep.
Really. Because of the sheer distance.
Kids find that endlessly fascinating. They find the idea that if you were, hundreds of millions of light years out into space and you turned a magic telescope on Earth and could see it, that what you would see was the dinosaurs roaming around it.
Yeah.
It absolutely blows their minds. They love that idea.
It blows my mind, and I'm 44. In fairness, I mean, the whole fact of looking back in time, looking out to the solar system, looking out into the universe, it still blows my mind. It's absolutely fantastic, and it's another thing that kids would be very interested in. And I wonder, is Andromeda right behind us and we just can't see it coming?
Wow. That's like the solar system. I mean, you can tell kids that, for example, it's a couple of seconds time lag between looking at the moon, 8.3 minutes, with the sun. I mean, there's a time lag with everything. It's not just these millions and millions of, it's just, even the sun is 8.3 light minutes away,
Yeah, we do an outreach with children in primary schools here, and we do things like we bring in different types of meteorites. Some are magnetic iron rich ones, but one of the things we love telling them is that if the sun went out right now, you wouldn't know for 8 minutes. And they're fascinated with all these little things, but they already seem to know a lot. When we go in, they're all have their hands up before we've even started. They have the little poem to remember the planets, and they know a lot. And I don't know how they know it because they're not learning it in school. We're going in as a kind of a fun day out for them, but they're learning it somewhere. They know a lot already, and they're, as John said, they're absolutely fascinated. It's wonderful.
Yeah, because even though we don't have to teach them it, teachers teach them it because kids find it really interesting. And just talking about interesting ways to teach that idea of the time delay between things as well. One of the misconceptions that students often have is that these rovers that are on Mars are being remote controlled, by people on Earth. And to some extent they are, of course, but the time delay means that you cannot do that like you drive a remote controlled car. And I was thinking, how can I show students this? And so what I did was I did a Chinese whispers chain. I had 2 remote controlled cars, 2 chains of students, and the students controlling the remote control cars were outside the classroom and couldn't see what they were doing. And so the only way that they knew to try and get their cars to a box on the other end of the classroom was for kids to whisper instructions down the line to the controller, and then try and drive forward or drive left. And you can imagine the absolute chaos.
That's good. That's good.
Brilliant. We take the kids out into the playground after we've shown them the whole solar system on a screen, and we take them outside, and we have those hopperoo things, those big, remember those things you can bounce on? Yeah. And that's the sun. It's the biggest one. And then we have various, we have a globe for the Earth, and we have various footballs and, giant balls. And we've even managed to put like a hula hoop ring on one to be Saturn. And then we space the kids out as far as we can across the whole playground and show them, get them to move around as if they were the solar system. And we have, the asteroids, we have we even use like Christmas baubles and everything for them. And we get them to bump off each other and, show them how some get shot out forever and others get sent in. And they love it, and they get a real sense of, it's what John was saying about telling the kids to whisper along the line and get a sense of the distance and the movement.
And it's actually very difficult to do that activity properly because it's almost always a trade-off between correct scales of one or another. Because trying to get the sun in a scale that's usable with almost any other object in the solar system and a usable distance scale as well is almost impossible. It's absolutely ridiculous. The sun has to be so much bigger than some of the other planets, otherwise they appear, less than a dot, less than a millimeter big. The smallest ones out, if you do the sun of something like the height of the classroom, and all right, kids, imagine that the height of the classroom is our sun here, then the Pluto is going to be several kilometers away, and a dot on a piece of paper. And that's an activity that I get students to try and do as well. I enjoyed letting them run miles away across a field.
We never had anything like that. I would have enjoyed any kind of scale, even something to do with it. It would totally have interested me. And I think it's a wonderful thing to be doing for any child, especially a child with any interest.
Yeah.
Today, children can actually speak to a real live astronaut on the ISS. The amateur radio in space setup is very easy. You just need a local radio amateur who can come in. He can set his radio gear, have a trackable antenna, and for about 10 to 15 minutes, the school can talk to the ISS and ask astronauts questions. Didn't have it in my day.
No.
Yeah.
People don't realise amateur radio gear was on board the shuttle 24/7.
Of course.
It was the emergency communication systems. There's a VHF repeater at Cape Kennedy, the Cape Canaveral Space Center. And I always knew when there was going to be a launch because I would log into it. I'm a radio amateur with Echolink, and it would have a message that the repeater is unavailable. It is on pre-launch lockdown. Because every time they launched, they took control of it themselves at the Space Center, so they could use it in an emergency.
Yeah, we tried to get some questions to Tim Peake. They did ask questions of the astronauts thing and threw it out to all the schools. I got all of Year 7 and Year 8 to come up with a question that they would ask them, and we picked the most common ones and put them in the hat. And unfortunately, they never got asked, which was a bit sad. So that's actually quite a good thing to know.
I'll send you a link. If you can have Neil drop me an email with your email, I'll get you a link to the amateur radio program with the ISS.
Lovely, thanks, Nick.
Welcome.
Getting back to Borisov just quickly, for those who may be interested in that comment, the Hubble Space Telescope this past week was instructed to look for it from Karen Meach, and the pictures will be released, I believe, on the 31st of July. So we will see how much of it remained, because I believe it fragmented on its way out, didn't it? It only got to about 2 astronomical units away from the sun at perihelion, but so we shall see what is left. This very carbon-rich blue comet. Very interesting comet too.
And how much do you think pictures make a difference in education these days and the ability to outreach to people? Because when we were at school, I mean, what pictures were there of things? What devices were capable of taking half-decent pictures of anything that was in space? Nowadays, kids can see pictures that are happening live on another planet. It's quite amazing, isn't it?
In full color as well.
Yeah. I was looking at some of the recent pictures of is it Cassis, the orbiter around Mars, that's doing some amazing high-res color photography of Mars, and just absolutely blown away at these images of another planet. And we're so lucky to have that these days. And 20, 30 years ago there was nothing.
Well, most of your students have got, even in their pockets in your classrooms, they've got their phones, and the cameras on their phones, if you stick those to telescopes, it can show wonderful images. They can they can go and photograph some really good moon features themselves, or you can get constellation, get Orion Nebula picks up well, doesn't it, Nick, on a mobile phone?
Yep, it does.
They can do a lot of stuff themselves.
I have to confess, when I'm choosing the cover for the magazine every month, I get advice from my 8-year-old grandchildren, my grandsons. I notice whenever we have them on display somewhere, the more colourful and the more dramatic, maybe an explosion or something, a comet, or I don't know, something that looks really dramatic, that's the one always the kids go for. So I always get a little bit, it doesn't, but I always say, well, which one do you think? That'll be usually the one then, the most dramatic. So I think pictures are very important for kids.
I think also the really good thing for children who want to do astronomy at school is that there are now telescopes that schools can book time on. The Liverpool telescope is one of them. And of course, there's a couple of others. I know for a fact that I'm going to mention it because I'm probably going to get told off elsewhere. SLU does have an educational section where schools can actually register, and for a reasonable fee, they can use the telescope, book time, take their images, and use them as part of the classwork, probably even for the GCSE in astronomy, or even key stage 4. Things have changed an awful lot. It used to be you had to have perhaps a local astronomer who would be willing to set something up so that the kids could come to the school grounds at night with their parents, and they could have a look through a telescope.
Yeah.
We have become, in some respects, very lucky. We have professional grade instruments at home. We are now, a lot of us take part in professional, what they call pro-am collaborations for comets, asteroids, planets, deep sky objects, variable stars even. So again, that resource is now something that's available to the schools. It had to be in the past. The school had to be well off enough to fund its own observatory, and hopefully to have a teacher who was astronomically minded. No Marvin jokes, please, Neil.
No, none at all.
So few schools have either of those things.
Yeah.
And if you think about, the number of schools and the amount of population that exists inside dense population centres, and even if they had either of those things, would still be unable to get a clear view of the night sky because of light pollution. It drastically cuts down on the number of children who've been outside and put their eyes to a telescope and seen something in space.
Yeah.
Well, touch wood, hopefully, once we get rid of lockdown and we get this thing under control, maybe schools can then start laying on trips to observatories out of town, so the kids can actually get their eyes to a telescope in a dark sky area. We have places, I know there's an observatory on the South Downs, I believe, that has an open door session for school kids. Kielder certainly does, or did.
Yeah.
Where your school can go up there for a few days, and spend the night using the telescope. I've been under the skies at Kielder. There, even on a campsite on the edge of the village, it is still so dark that you can look up to the sky and you can't find the constellations very easily because you can see so many more stars than you can normally on the edge of a town.
Yeah.
So there is stuff available, but it's getting it organised, I suppose, really, and I'm sure you'd agree with that, Johnny.
Yeah, and that can be a difficult and time-consuming thing, but I think it's something to definitely push for, and making a little note to myself of things that you're talking about.
There's a mobile planetarium that will go around to schools, and I think they've fit about. It's like a blow-up thing, like a round tent. It fit about one class at a time, and I think the kids have to pay maybe $5 or something. It's not a lot, and they all get to have a planetarium experience, but in the school. It can be done even indoors in the hall if it's a wet day. It doesn't have to be outdoors.
Yeah, there are a number of people who do those sorts of things, and I've been in several of them. And I will say it actually does depend on the operator to some extent about how good the experience it is.
How good it is.
Some of them are quite inspiring, and some of them are considerably less so. So yeah.
Anything else you'd like to tell us about astronomy and education?
Well, yeah, just about the other stuff that we do cover. I've said what we're supposed to cover, but there's which is not very much, unfortunately. But there is an awful lot of other stuff that we do cover, and certainly then one of the nice things about space is that certainly if you are a confident physics teacher, you can dip in and out of it in almost any other aspect of the physics curriculum that as you teach through it. The physics curriculum is, generally speaking, designed to try and relate things to the day-to-day experiences of students. But there's always occasions where when you're teaching electromagnetism or you're teaching about waves that you can dip in and out of some of the stuff that happens in the space curriculum as well. The things that we tend to sort of go through them with are the difference between gravity, weight, and mass. What the sun is, nuclear fission, nuclear fusion, which they do find really fascinating as well when you talk about nuclear weapons and relate these two things to it. Space exploration is something that we'll always spend a couple of lessons on at Key Stage 3 and a couple of lessons on at Key Stage 4, and give them a STEM type project to do of here's your money, where are you going to go, why are you going to go there, how are you going to spend it, what are the decisions that you've got to make in terms of the spacecraft you make and the people you take and all this, that, and the other. And you can relate it to the type of people that you'll take along as well, and talk about some of the experiments they had where they've locked the Russians away for a year or wherever it was in the thing, and seen how crazy they've all gone. And even kids who aren't scientifically minded, that interpersonal relationship really brings them into it as well, and they love talking about it. And you can always relate as well. One of the important things as we go through GCSE science is the idea that that ideas have changed throughout time. Just because we're teaching you this now at the moment in this classroom doesn't mean that it is the absolute gospel truth, because just look at what people used to think back then. All of the scientific process is the idea that evidence changes throughout time. And that's something that I hammer home to children all throughout their time with me in school. Just really to, regardless if they go off to do a scientific career or not, just to make them critical users of evidence in this world that we live in today, because there's so much that gets thrown at them, and they need to be able to have that skill more than anything else when they leave high school. Kids find it bizarre that when I was at school, we knew of no other planets around any other stars.
Yes.
And now it's common knowledge.
Yeah, exactly.
Going back to the Rosetta space mission,
Yes.
to that particular comet, which I have always had difficulties pronouncing.
Churyumov-Gerasimenko.
Thank you, Neil.
Yeah.
There was
Not Strashman.
Swashman-Wackman 1, SW1 in London.
No, next one.
Anyway, basically, an example would be when Rosetta was going on, I was talking to a comet scientist who had written a book. It was about 4 or 5 inches, maybe 6 inches thick, on comets, on the chemistry, on the composition of comets. It's quite a good book, actually. It's a brilliant book. And his publisher asked him, in light of what's going on with Rosetta, can you update it? He was halfway through updating the book when some of the results from Rosetta started coming through. And he says, apparently he said, I picked up my manuscript and I threw it on the fire because it was a waste of time. Yeah. Because everything that we knew about comets had just been made obsolete.
Yeah.
And he said that he knew of 3 people who are also writing books about comets who had just quit because Rosetta had just made all their research obsolete and worthless, because things had changed so quickly. Literally from the minute of Philae's bounces and misadventures on the comet, and to all the information gathered by the home-based probe, everything just went out the window. Mm. Yes, they're brilliant books to have to see how our knowledge moved on.
Yeah,
and that's true of some of my Lunar library. I have books by Patrick Moore going back into the 50s.
Yeah.
At that point, everybody thought that the craters on the moon were created by volcanism.
Yes.
Volcanism was considered the best way to explain cratering and the mare. Now we know it's a combination of the late Great Bombardment. There was some volcanism, but that was only kicked off by the impacts.
Mm-hmm.
And of course, our theories on how the moon formed have all changed.
Yes.
We went from being a huge chunk of the Earth scooped out in what we now call the Pacific Ocean, to actually being a collision between the Earth, the young proto-Earth, and a proto-Mars-sized planet called Theia. And when they collided and coalesced, the material thrown out ended up becoming our moon. Why do we think this is probably close to the truth? Because in the rocks and soil samples brought home by the Americans and the Russians, they were able to find such a close similarity, even down to some of the isotopes.
Yeah.
And some of the actual rocks themselves. They could find exact Earth copies and analogs. Yeah. So that's mean our whole understanding of the moon has completely changed almost overnight again with Apollo and with the Russians bringing back their samples. It started back in the late 60s, and by 72, we were thinking, well, it couldn't have been this way, because if you look at how the isotopes and the actual rocks are on the moon, there is a huge amount of stuff that's common with the Earth. So it kind of narrowed everything down. And I think the final nail in the coffin really was it was just totally impossible for the Earth to throw off enough material, even as a protoplanet, to form the moon. Because there are sufficient differences in the rocks and in the chemistry of the soil for another planet to have been involved. So, it's amazing how fast things change.
Can I tell you a funny story about the Rosetta mission? John will enjoy this one. That the mass spectrometer on Rosetta and Philae, they measured all the chemical compounds and the compositions, and it's water, carbon monoxide, carbon dioxide, hydrogen sulfide, ammonia, formaldehyde, methanol, and sulfur dioxide. So basically, it smells like a smelly cave, maybe that a dog peed in. And
lovely.
Yeah, sends us postcards, and they're impregnated with the smell of the Rosetta Comet. So when we go to the school, we pass it around and we ask the kids, we say, what do you think it smells like, And they sometimes come up with the exact thing that I just said, but various different ideas they come up with. But one little boy piped up there before all the lockdowns, and he put his hand up and he said, "It smells like Granddad."
That's how you get kids interested in school. It smells like farts and it smells like my granddad. I mean, the kids are going to love it.
Fantastic. I have seen a demonstration actually of making a comet to be done in a school laboratory using a whole load of crushed dry ice and carbon compounds and all sorts of things. And you could actually squeeze it all together and make that sort of dirty snowball. It didn't have ammonia in the mix though. It had vodka. So the ethanol was in there, but yeah, I think the ammonia would be a good one. Pass it around and get kids to smell it. I like
it's great. Well, it's I don't know if they're still available. We got them from me, so we got a few, and the kids just love it when we pass it around.
Yeah,
they do.
And I think that's something else. A lot of the space agencies, particularly the European Space Agency and NASA, if a school approaches them for materials, they're there. Oh, yes, we can help you with that. And they'll point you in the right direction to find out how to get the stuff. 9 times out of 10, it's free. Because at the end of the day, they're sending out all this wonderful material, and the kids are getting to see where actually their parents' tax money is being spent and what it's being spent on.
Yes.
And I think that was the important thing. They get to see, oh, well, the money that the tax man takes, he put 20 pence on it went onto the space mission, and it told us what a comet's really like. That is perfect payback, because it means they can say to the governments, well, you know what, we justified you giving us 20 pence for that space mission to a comet. So it's one of those really fun things. They like to help the kids.
Yeah, there's no shortage of resources out there to try and make science teaching more interesting these days. The number of people of my age who I speak to and who would tell me that they always found their science lessons boring when they were at school, and it breaks my heart because there's no excuse to have science lessons being boring. I teach kinetic energy equation by making and using bullwhips in the classroom. I teach specific heat capacity by doing fire eating in front of the kids because I'm a professional fire eater as well. And there's so many cool things that you can do to just get kids on board and make them interested in your subject.
And of course, obviously you need to check the material. There's so much stuff on YouTube put out again by the space agencies, again by scientists. In fact, I think you can go back at least 5 years on the Sky at Night now online, and you can see all the old shows and just see where we got it. We're so close, but we totally got it wrong, as Patrick puts it in one show.
Yeah, Martin Mobley's YouTube station. You can go back to, I think there's one in 1968, and you certainly from the mid 70s onwards, you can watch nearly every single episode that was made of it.
Yeah,
and it's all wrong. As we were saying, everything back then is all wrong. they were approaching Mars, and he said these dark patches could very well be vegetation, but we don't know yet. And of course, we now know no. Venus, they thought, was covered in vegetation.
Yeah,
black holes virtually didn't exist. Nobody believed that. They were on paper. Yes, they do exist, but we don't know. But now, black holes, every single galaxy's got one. So
and
it's all changed.
That's it, and it's challenging children to realise that. And to then put them in the position of going, well, look, what is it that you're going to discover? What's the thing that's going to have your name on it, 20, 30 years in the future? The science has not already all been discovered by those, old white guys in black and white photographs. It is changing all the time. It's developing all the time. Someone in this classroom is going to have a role to play in that and making it relevant to them. There was a fantastic body of work that was done about why is it that children all say they really enjoy lessons in science in school. Why is it that they see the relevance of science to them in their day-to-day lives, but then so few of them go on to do scientific careers or take scientific a higher education? And it was basically because they see science and scientists as not them, as someone else, that there is this separate body of secret people who are scientists. And it's trying to break through that misconception. And actually, look, it's all around us. There are people, in our local community who do this. And actually, the reason why I got in contact with Neil in the first place was because I put out a massive, what's the word? We asked all the children to go and speak to their parents and ask them what they did. And Neil came back on that as he was this astronomer in the local community. And that was the entire purpose of it, was to try and find people local to us who could come into school, talk about this, that, and the other, and make children realize that, it's them, it's people around them, it's everything in their local community. And it could one day be them in the future as well.
Yeah.
We can put this into a context that the kids will understand. They may be the parents or grandparents of the first people to step onto Mars.
Very true.
That just shows you how close things are coming. Perhaps in your classroom, Johnny, there may be someone whose either son or grandson may actually be the first person to step on Mars, or may go to the asteroid belt as an astronaut or as a scientist.
Go back to the moon even.
Yeah, but that's happening already.
Yeah.
The Gateway station's going up. Even though the moon is seen as a stepping stone to Mars, lunar colonies will eventually happen.
This is definitely to be something for the next generation, our children, our grandchildren. Is it going to be complete reality? Which even when I was a kid in the 80s, it was so far off and unthought of that was never going to happen. I mean, our own kids, our own grandkids, that's going to happen. I mean, that's absolutely amazing, and it blows my mind at this stage.
What got me into astronomy was James Burke, Arthur C. Clarke, and Patrick Moore. It was the coverage of Apollo 11. I actually skipped school the next day because I stayed up to watch the landing, and by the time that had happened, it was so late I would not have been in a good state and fit state to go to school anyway.
Oh, yeah.
The thing was, we had the Apollo program that kept an awful lot of kids interested. We had Star Trek. We had Jerry Anderson, the UFO in Space 1999.
Yeah.
To feed us as kids, to push us without thinking into looking at science.
Mm-hmm.
By the time I left school, I had 2 telescopes of my own.
Yeah.
I've had 3 since, each one a step up from the previous one.
What?
We're at a point now where a child can be in a classroom in Australia and they can be on a telescope in England imaging the night sky. Or the child can be in school in the UK and they can be using Siding Springs Observatory and the iTelescope network to image Eta Carina in the Southern Hemisphere. We have that capability because we have the internet.
Yes.
And also, don't forget, Chris Lintop does that program, doesn't he? And I've forgotten its name completely. But there's been children discover comets, hasn't there?
Yes.
In the classroom, they've discovered comets and asteroids and all sorts of
a supernova stuff. As well was a high school child, I believe, spotted a supernova at one point.
Yeah.
Yeah, that's amazing.
And one upper school who was moving on to college was involved as an intern in a program. And I want to say she discovered an asteroid or something. or a near Earth object.
Yeah, near Earth.
That's what's now available.
Yeah.
The school teacher in Holland, was it?
You're thinking of Hanny van Arkel and her.
Hanny's.
And the Verwerp.
Yeah.
That was done through the Zooniverse, through Galaxy Zoo.
Yeah,
It's still going. It's got all kinds of projects schools can take part in.
Yeah.
There's the Bionic project, which allows you to number crunch for science projects. And you get this is what gets me. This is what makes it so beautiful. If you're involved with SETI or with any of the other science projects, even with the Zooniverse, they there's a discovery found. And when the paper's done by the scientists, by the boffins, your name's on that paper because you put time and effort into the results. So you can take part and have your name on a cutting edge science paper today. There's still, as I say, the Zooniverse is growing. There's all kinds of weird and wonderful projects there, and they all are very useful, and they all need help. If it's spotting domes on the moon, green peas in space, looking at weather data from old ship's logs, which is very relevant given climate change.
Yeah.
The papers that are produced with the information that's done and found, they automatically put the name of the people who worked on the project. So you may get Chris Lintott first, and whoever, Paul Abel, but in that list of contributors to the project, your name will turn up. I know for a fact that I am on 3 papers due to number crunching for various projects using Bionic on my computer. In fact, they came to me and said, "Hi Nick, we're writing a paper. You've done a big chunk of the actual number crunching for us. We need you to change your name for your profile so we can put your name on it. We can't put your nickname on the paper." So I went and changed my profile so they could put my proper name on a science paper.
Excellent.
Clever thing.
Cool.
And that is available to kids today.
There's a good book by Chris Lintott on the subject called The Crowd and the Cosmos. It's explaining all about it. It's good, an interesting read.
It's a very good read, and it is. I do recommend it. I reckon it would be a cracking good book for your kids, Johnny, to look at, because he gets you enthused. He gets you enthusiastic. He draws you in, and he explains things in a very good and easy manner. And he doesn't scare you with frightening math.
Lovely. Adding it to my notes from this evening.
Hey, you can add the radio show to your class list if you want.
Essential listening on the curriculum.
And something else that might get them interested is Tom Cruise is going to be going up to space this year at some stage. He's filming a movie on the space station. So I don't know what it'll be about, but eventually it'll be of interest, I'm sure, to kids.
Yeah. It'll be about him, and it'll be about Tom Cruise. That's what it'll be about.
Have they chosen him because he's quite short, and therefore the price per kilogram of Hollywood star is a cheap thing?
He's a bit spaced out anyway.
His ego may not fit in as quick as he will. But,
that's right.
He's going to space, and he's filming many scenes. Of course, he can do this according to him. So, I mean, all I can say is best of luck, and I hope he doesn't constantly vomit. Although he probably will, but even if he does, he'll never admit it. So, best of luck, Tom. Best of luck.
And that's another interesting thing as well, actually, that's changed in recent time, is the physical access to space. That we're now seeing, Virgin Galactic, is just coming online, isn't it? And people actually being able to get physically up there. And that was something that was never, ever possible in your wildest dreams. You had to be an astronaut for that to happen when we were children.
Actually, I think the first space tourists are going up this year. Yeah. So,
I believe so, yeah.
Well, it's part of the how to make money from the ISS plan.
Interesting.
Will allow space tourists. It's going to cost an awful lot of money, and you're going to have to make sure you do exactly as you're told from the get-go. Otherwise, we'll kick you out the airlock, I suppose.
Don't press that button.
it's a future thing, but of the space hotel they're planning to make up in space, and people are going to be able to go up and spend the night and look at the orbit. And you know what? That's actually fantastic, but it will be within anybody's grasp of financially. I have no clue. It seems to be
start with billionaires
out of the price range of anybody really. But
well, one day Ryanair will probably get involved. And
and we'd all die, Anne, though. That's the problem.
they leave you near the moon.
Near the moon. Somewhere slightly near the moon with a connection. Yes.
If you think about it, on the ISS already, they've been testing what they call Bigelow habitats. They're habitats which could be blown up with air, filled with air. They expand to become a living module. Now, obviously, the plus side for testing it means if there's a rupture in the skin, in the space station skin, they can possibly clamp one of these habitats over the damage, which means they can hopefully then put an atmosphere back in, and it's the shirt sleeve environment to do the repair.
Right.
Or you can use the habitat as a lifeboat.
Oh yeah,
and
very interesting.
Yeah.
As I say, I think that's probably the reason they agreed to test it on the ISS, was because the potential to become a lifeboat if there was any form of rupture through either a micrometeorite or a piece of space junk actually hitting and piercing the skin of the space station, was very handy. And obviously the idea for these Bigelow habitats was originally the moon. But they said, no, we'll test them somewhere very close to Earth if you don't mind. And the best place to do it is the ISS. So in a lot of respects, going back to the moon does make sense. It's easier to get to the moon than it is for a rescue, than it is to get to Mars to rescue your astronauts, cosmonauts, or taikonauts.
Oh, yeah.
Basically because we know how long it takes. We can, if worst case scenario is, we can do a direct, instead of doing the figure of 8 that the Apollo astronauts did to gain speed, extra momentum in space, you can go direct to where your target is. That's the whole point of the Orion capsule. It now takes more than 3 people. What people didn't know was when we had Skylab, the Apollo command modules were modified. They took out all the lockers and everything, and so they could put in extra seats. So they had a Saturn 1B on standby for immediate launch for a rescue mission to Skylab.
Wow.
And there would be only one pilot on the mission. One astronaut would fly those missions, because the other 3 seats could then be utilized by the crew of Skylab to come home. So if something went wrong with a command module and service module whilst connected to Skylab, they had a backup unit on Earth on top of a Saturn 1B waiting and ready to be used. Never used at all. They actually used the same idea, but with a second space shuttle on the last servicing mission to the Hubble Space Telescope. In fact, President Bush said in order for the servicing mission to go ahead, there has to be a second shuttle ready for an immediate launch.
That's right.
So that's what they did. They literally took a leaf out of the Skylab rescue handbook and turned it into the Hubble rescue handbook, but with the shuttle instead of a Saturn 1B. We have SLS coming on stream, they hope, next year. Artemis 1 is due to go and fly around the moon unmanned. They hope later this year, early next year. We got the Dragon capsules now in regular use and commuting to the ISS. Space has changed. When I was growing up, it was Apollo. Well, I just about remember Gemini, but Apollo, and then Apollo Soyuz, Skylab. Then we had the ISS and the space shuttle. We lost the shuttle. We had no way for Americans and Brits to go to the ISS except via Russia. Now, through using a independent company, SpaceX, they can now do it. Steve Bezos has got his space rocket coming on stream. It's supposed to be as powerful as a Saturn V rocket. He has his own space capsule. They're all competing to go to the moon.
And think how many other countries are involved in space exploration these days. I mean, the UAE has just had a satellite go into orbit around Mars, haven't they?
Yep.
I mean, there's so many other countries and children in those countries and people in those countries who can now think, oh, it's not just America and Russia who are capable of doing space stuff. I can as well, me in my country, wherever you are in the world. India, China, they're all getting involved in it, aren't they?
Yes, yeah.
India's going to the moon with a manned mission. I hate to say this, most of their technology is suspiciously almost Apollo-like. I suppose if the idea works, why change it? NASA's gone back to a command module and service module idea with Orion, except it's bigger.
Yeah.
And of course, Japan has its own space agency and has been launching satellites. They've actually beat everybody back with a sample return from an asteroid.
Mm-hmm.
They beat everybody back.
But there's also great international cooperation. I mean, the Chinese mission has just arrived at Mars too, and like they're cooperating with the Japanese Space Agency. The Hope mission that John mentioned, there's a lot of American involvement. So it's not just like one country on its own. There's so much great, generous cooperation between scientists. It's wonderful, actually.
It's what you want, though, for what they're trying to do and what everybody's trying to do. Everyone, I think, has similar interest or similar end game, but it's to get people right in the meantime to get to the same end game.
Yeah, and we need cooperation. Yeah. We need global cooperation with everything, and it's the scientific community are leading the way there.
John, here's a title for you: Voyage to the Planets. It's a docudrama by the BBC about an international space mission. Mm-hmm. To literally do a grand tour of the solar system, like the Voyager probes did,
mm-hmm.
and some of the Pioneer probes. It's an international crew. They have an international spacecraft, and they go across the whole of the solar. They visit comets. They go to Venus. They bypass Mercury. They go around the Sun. They visit Jupiter, Saturn, Mars. It's brilliant. I think it's one of the things we're lucky in this country that we have the BBC. I know a lot of people knock it, but the BBC puts out the sky at night. It's a very much a minority show, but it's there. It's been saved and it's still going strong. They do excellent scientific shows like Horizon. They have a terrific back catalogue. Some of the information is obviously out of date, but still fairly useful. But when they do a docudrama, boy, do they try to make it as accurate as possible. And as I say, it's various. They've broken it down into each planet as an episode. So that might get your kids going as well.
Nice, thank you.
There's actually another book about the Horizon. The whole a chap called Alec Nisbet, I think his name was. He produced most of the Horizon productions over the years, and he wrote a book about it. He's retired now, but again, it's really interesting how they did it. It's maybe not so much for kids now, but it's just interesting how the whole thing and the accuracy, as you say.
Some of the story of the Jodrell Space Telescope, is still fairly good because although they upgrade the Mark II dish on a regular basis, and it's now part of Merlin, it's something that's will survive the test of time on its knowledge, on its fact base, because it's pretty much the story of the creation of how Jodrell Bank came into existence. And again, it's one of those really unusual stories. It started in radar in World War II with radar. All the equipment for building Jodrell Bank was ex-military radar and radio equipment cobbled together to build a radio telescope using long lengths of wire. And it just grew, and in the end, they built the Mark I and Mark II dishes, which are so much a part of the Cheshire skyline. But that's the thing that can confuse kids. And in fact, most schools can build a radio telescope these days to listen to Sagittarius A, the black hole at the center of our galaxy. They can listen to Jupiter. They can listen to the sun,
yep,
and other things. I think it's called Project JOV. It was set up by NASA originally. It's definitely got the website's still up and running. And you can build the equipment as part of a science project. So you can involve physics, electronics, and astronomy all in a science project to build a receiver and set it up to listen to space.
Yeah, again, so few children appreciate that we actually look at space using so many more wavelengths of the electromagnetic spectrum other than just visible light, because a visible light telescope is the thing that they're most familiar with, and without realizing that actually we get so much of our information from radio telescopes, X-ray telescopes, all sorts of different things.
Listening to space and listening to planets and listening to the sun and listening to anything like that is mind-blowing to a kid, because they don't probably think that these things make noise. And to listen to it, you're like, wow, then you're listening to it so intently, you're like, these things all have their own noise. And I think the noise of planets, apart from the actual, spectacular of them, just looking at them, is also an incredibly interesting thing that kids might have some interest in.
Oh, they would, yeah.
I just want to quickly go back to the Mars missions. The UAE's HOPE mission was launched by a Japanese rocket, the Mitsubishi Heavy Industries H-2A. China actually used its own rocket to launch Taiwan-1, which is Heavenly Questions, which means Heavenly Questions. So China actually launched its own space probe on its own rocket. Sorry, I had to correct that.
Another thing that I'd say kids would be really interested in, and I know Neil knows all about it, and even the name the kids would love, Far, Far Out.
Oh, far out. Yeah, that's an interesting object, isn't it?
Yeah.
Yeah, it's a trans-Neptunian object, which means it orbits beyond the orbit of the planet Neptune. It was discovered in 2018. Its actual proper designation is 2018 AG 37, and it's been discovered at 132 astronomical units away from the sun. Now, there's a huge amount of questions about if it is that far away, because there's not a very long observational arc on the object, just a couple of years. It was found by Scott Shepherd, David Tholen, and Chad Trujillo. I think they're Mauna Kea. I think they're based at.
Yep.
And the aphelion of the object is 144 astronomical units away from the sun. Perihelion is 27 astronomical units, so that dips just inside the orbit of Neptune, and the period is currently thought to be 796 years, plus or minus 941 years. So there's a big differential there. The diameter is up to 400 kilometers. The apparent magnitude is right on the limit of what we can see with our ground-based telescopes at the moment at 25.3. But if it was its absolute magnitude, so if it was placed in the perfect position of 1 astronomical unit away from Earth and Sun, it would be magnitude 4, so it would be a naked-eye object. And as I say, it's only been observed 9 times in the past 2 years. As I say, it will be at aphelion, they think, in 2158, and the orbital period is around about 1,000 years. So I was having a quick look as well earlier on, and I looked at a comet called Donati, 1858 L1 Donati, which was a great comet, visible with a naked eye, big long tail. That currently is 145 astronomical units away from the sun, and that was at perihelion in 1858. So, as I say, it's an object that is a long way away. It's big enough to be spherical, and it will probably look very, very similar in colour and appearance to Pluto, the pinkish, which is caused by the tholins there. And I thought to myself, let's work this out. So imagine if you was driving a car at 70 miles an hour and you left Earth, and we could stop this far out in its tracks right now. We could just stop it where it is now, and we got in our car and drove at 70 miles an hour, non-stop to it. It would take around about 19,500 years to catch up. So that puts into perspective. So children were thinking about how far away is 145 astronomical units. If you get in your car, you drive at 70 miles an hour, in 19,500 years' time, you'll catch it up. So that shows you just how far away.
Kids will love that. It blows their mind.
Yeah, exactly.
It'll blow their mind.
These things
we'll try to rethink. Sorry.
It's amazing that we can see these objects. I mean, in the days like we were talking about a little while ago, Patrick Moore, and as you were saying, Johnny, when we used to get the old pictures, the old black and white, basically rubbish pictures compared to what we see now and take for so much for granted. We didn't know these things existed. I mean, the first trans-Neptunian object, of course, was Pluto. And there was not another confirmed one until I think it was David Jewett found one in 1992. I'm sure Nick will look this up, but I think the second one was found in 1992, some 62 years after Pluto. So the solar system is expanding. It's, you've got to remember that I think it's the Pioneer and Voyagers are 130 astronomical units away at the moment. They were launched in the 70s, weren't they?
Wow.
So, and they've been traveling since 1977, and
they never need to stop for a break or for water or to go to the toilet. They just keep going. I mean, it's amazing. Like when you say to the kids, we need to sleep, we need to eat, we need to use facilities. They don't. It's just on and on and on.
Yeah.
Yeah, non-stop for 20,000 years. But we've got to remember, I think it's only inclined at 18 degrees to the ecliptic. Now, I remember the guy who's involved with Mr. Brown about the Planet 9 scenario. I think his name was Constantine, but I can't remember his surname. A very clever chap. He always said that objects were always deflected or they always come back to where they were deflected from. And the far out comes within a close distance. I think it's 4 astronomical units to Neptune. So it obviously was floating around there at the time, and it's only inclined to the ecliptic by 18 degrees. So Neptune has had a big, big part in throwing this one out, because the whole idea of trying to find these trans-Neptunian objects is to confirm the possibility of a Planet 9 that is out there altering these orbits of planetoids like Sedna, for example, and Eris as well, I believe. So we're trying to find proof of Planet 9's existence, but it looks like Neptune is responsible for this one. So it's a huge distance away, and it's the farthest thing that we've been able to see with a telescope.
And it's also proving that we are non-stop seeing further and further and further every single time.
Yeah, and this thing is only 400 kilometers in size, which I know is big, but to be that far away is incredible that we can see it.
Yeah.
It was 2018 they found it, but it's taken this long for them to find the orbit, because they needed time, didn't they? Because it's moving so slowly in our skies.
Yeah, and there's only been 9 observations of it. So, there's not a lot to work with. And as you say, it's moved such a tiny amount. That's why there's such a huge differential in the positioning of it. And it could be a lot closer. But at the moment, it looks a long, long way away.
That's why it's called far, far.
Yeah.
I think what you're referring to, Neil, was QB1 1992, discovered using a 2048 by 2048 pixel camera at the University of Hawaii 88-inch telescope. It orbits at 44 AU, about 250 kilometers in diameter. Yeah. As soon as they found that one, they started finding even more.
Exactly. And of course, this is they think a lot of the things out there, we have a thing called a scattered disk. And that's responsible for a lot of the shorter period comets that eventually migrate inwards through these close interactions with the planet Neptune and eventually Uranus and then Saturn. And of course, our friend Jupiter, as we said earlier. And then they eventually will become the periodic comets like Churyumov-Gerasimenko and things like this, and Halley even.
Yeah.
Or Hawley, I should say. And they will eventually turn out to they migrate in. And a lot of the objects in the Oort cloud are believed to have been deflected the other way from Neptune and then found their way out to the Oort cloud. But I mean, it's only well, I mean, as you said, the sun's grip basically runs out at that distance, doesn't it? So these things are only very loosely bound to the solar system as well.
The interesting thing is the solar system doesn't end until at least 3/4 of the way to Alpha Centauri.
Yeah.
Which means our solar system is actually very, very much more massive than we ever actually believed.
Yeah.
Speaking of Alpha Centauri, I think they've found another couple of planets that might support life. So in 2016, an Earth-sized planet was discovered orbiting Proxima Centauri. So and that's like, as you said, it's our nearest neighbor. They think it's in the habitable zone, which is called the sweet zone or the Goldilocks zone.
Yeah.
Where liquid water could exist on the surface, which of course is the first thing for life. The parent star is a red dwarf, so it's not like our sun, and it means that it's cooler. So the planets need to be nearer. But then red dwarfs are inclined to flare, so they could burn off the atmosphere. So it's all very up in the air. But still, in all, it's a especially for things for children, if they're interested in stuff like that, that it could actually support life. There's a new study now called NEAR, which is near Earth in the Alpha Centauri region, and it's a project by the European Southern Observatory, where they're searching for planets just like this, and they use similar to SOHO, the thing that blocks out the middle of the sun so they can see what's around the edges. So they use the same kind of technique, so that they block out the light of the star, and then they can look at little heat signatures of planets moving around it. And they found this anyway. But the one that they're looking at, it's about Neptune size again. And it's about between 1 and 2 astronomical units from the star, which is the same distance about as Earth is. We're 1, so it's somewhere around that region. So about 93 million miles, 150 million kilometers. But it's still not confirmed. It could actually just be a bit of dust floating around at the moment, but they're looking at it still, and it's just one of those candidates for life anyway, which is always fascinating for kids.
Yeah, kids absolutely love the idea that there could be living things out there. It's always the number one question whenever you start the space topic. Sir, do you think that there's life somewhere out there?
Yeah.
And it's great fun, running through the Drake equation with them and talking about the percentage chances of these things. And yeah, love it.
I think if we're going to find life, we actually may find it closer to home than we think. The interesting thing is that Europa has an ice-covered ocean. Now, the fact that both the European Space Agency and NASA are planning submersibles to go to this moon, to be inserted through the ice, and then to travel the European ocean in search of possible life, which is probably a fantastic. It's going to be a fantastic thing anyway. There's actually a place closer to home that may harbour simple microbial life, and it's always been on our doorstep. We've been so busy looking for planets like Vulcan, around Eridanus, that we've forgotten about potential targets closer to home that may harbour life. Mars, I don't think ever did, but I will still be pleasantly surprised. It could have had microbial life in the past. Any current life may be human bacteria and viruses that were taken there by the Viking probes. Yeah. And we know that they will survive the trip to Mars because they've survived outside on the skin of the ISS as part of a scientific experiment.
Yep.
So we may have indirectly seeded life on Mars, but it will be something we would recognize a lot easier than, say, on another planet.
Yes.
And to be honest, I always say this, we humans are a nasty, juvenile and violent species. If there is intelligent life out there, they probably quarantined us, and either we've missed it by a couple of trillion years or we're a couple of trillion years too early for it. Who knows?
I reckon maybe both, but we're probably definitely not something that anybody's interested in as much as we think we are. We're not.
Yeah. John, have the children any interest in tardigrades? The little water bears that seem to be able to survive on the outside of the space station and the top of Mount Everest, and they can dry up and rehydrate. And have you heard of those?
There's always some kid who loves a tardigrade. Yeah, absolutely. And there's
I'm that kid. I love.
They look so cool, though, don't they? When you see pictures of them, they look amazing.
Well, they even made it into Star Trek Discovery, as I remember, in the first season, first couple of episodes.
Ooh.
Giant tardigrades.
Giant one.
Giant. Ooh.
Wow.
Oh dear. It's funny, isn't it, how Star Trek's affected us all, really. One of the shows that really got a lot of people into science in the first place.
Yeah.
I want to be Mr. Spock, or I want to be Captain Kirk or Dr. McCoy.
Yeah, I love the fact that within our pockets these days, in the shape of a mobile phone, we've got something that's, almost got all the capabilities of a tricorder that they had, when I was growing up. These were space age ideas, and here it is, in reality, in my pocket. It's mental.
Well, the very first computer chips, the first computer processors, were built for the American space program by Intel.
Yeah.
Then they just kept refining them, and they got, as I remember, Voyager technology is TTL, transistor logic. ICs are now go on to space probes, integrated circuits with thousands and millions of transistors on them. Well, definitely thousands, because there is a limit to how much you can miniaturize a transistor, which is why we're looking at optical computers and quantum computing. But as I say, everything we have on our mobile phones today is a trickle down from space and military programs.
Yeah.
The CCD cameras that us astronomers use were from SpySats, originally built for SpySats.
They saw the MODs originally, and they were literally for looking at your neighbours, looking at your other countries, and that's basically what we have now on our own phones.
Yeah.
And do you remember on Star Trek, they'd just ask the computer a question and it would answer it, and now we have Alexa.
We have Alexa, we have Siri, we have all sorts, yeah.
There's a good cartoon out where some young kid connects Siri and Alexa and they take over the world.
It's not far off, Nick. It's not far off. And I mean, there's some wonderful little child out there with a brain beyond all of us that is doing it and is going to take over the world.
Or turning a lawyer into a cat.
If you think about it, the computer on the lunar module was so huge, it had to be programmed literally by hand.
Yeah.
Now, we have 500 times the computing power of the lunar module in our pockets every day.
I love telling kids these sorts of things, and then it makes me feel really old, unfortunately.
Not as old as me. But my generation had Apollo. It had Mercury, Gemini, and Apollo to get us into astronomy. And as I said, it was watching Patrick Moore, Arthur C. Clarke, and James Burke talking about how things would work and be done, that captured my interest. So instead of going and charging around the playground at break, I used to go into the library and pull out all the space books and go through them. In my mind, I'd be building a rocket that would perhaps go to Mars. In fact, the greatest thing is I can just remember Dan Dare originally, and certainly in the reprints, and he had a spacecraft called the Anastasia. And it's interesting. You look at the Anastasia, and you look at Elon Musk's Mars spaceship. They're almost the same. He wants to build Moonbase Alpha from Space 1999. So it's amazing how British science fiction has helped enthuse people and influence.
If I was going to build a space rocket or anything like that, it would be something I read or something I thought of when I was a child, because I'd want it to look that way. So I would go out of my way to make it look that way, because that's the dream, isn't it?
Well, I think it was more Flash Gordon for the Americans. Maybe. But as I say, Dan Dare, I mentioned Dan Dare a lot because I think in some respects, a lot of what was prophesied almost has come to pass in a lot of respects.
That's been true, yeah.
In fact, here's a little known fact for you. The British rocket program in the 60s was actually ahead of the Americans and the Russians. because we were launching Black Knight rockets from Woomera in Australia, and we actually were able to successfully launch and put scientific instruments into space on a regular basis before the American space program actually got as far as it did. The Americans were having a lot of trouble with their rockets up until Sputnik happened. They had a lot of disasters with unmanned rockets. We were using Black Knight, and we still have one of the oldest satellites that's still alive in space. It's called Prospero.
Is it still working?
Still working.
Wow, that's fantastic.
And the engines for Black Knight were tested on the Isle of Wight, and the actual stands are still there, and they're part. You can actually go and visit them because they're actually part of the cliffs.
Oh wow!
On the Isle of Wight, and they're actually a tourist attraction now.
Well, that's wonderful. I mean, I'm sure kids will be incredibly interested as well.
People don't realize how far ahead we were actually of the world. And of course, the other story about rockets is when I was told by a very old member of the British Interplanetary Society. And he said basically it was the Blitz. It was during the war, and they were all in a pub.
Yeah.
And suddenly they heard this almighty explosion. There was no warning or anything, no sirens, and it was the first V2 attack to be used as a weapon. It had just come in and exploded. Mm. And there's these two young men dancing in the street at the time, and people thought they were absolutely bonkers because what had happened, they had just seen the first real rocket fly. Even though it was being used as a weapon of war, it was the first actual rocket that would be capable of going to space. And V2, the V2s were used by both the Russians and Americans as part of their early space program, and they can actually reach the space. They could have reached the space quite easily.
The same technology completely.
Yeah. So as I say, everybody thought they're absolutely nutcases. Why are they so happy about it? Because it was the first real rocket ever to be used. Yeah.
Necessity, unfortunately, is the mother of invention, and even the horribleness of war was a necessity of stuff they needed to learn and needed to do to get past whatever situation they were in, which obviously brought people on to the next thing, but it is necessity, and you will find a way, and then we can hopefully use it for good after that, or for betterment of man.
It was eventually, and von Braun wrote a book even before Apollo called Project Mars, in which he postulated an SLS-type rocket,
right,
as twice as powerful as the Saturns he was developing already, that could be used to send astronauts to Mars. And the book is available as a PDF online because the copyright's on it expired and everything. You can now get it online as a PDF. Right. I've got a physical copy. I've read the book. It's a lot of mathematics in it. He goes into a lot of maths, and there's a lot of really dry stuff about logistics.
Yeah.
But he was already working to go to Mars, even whilst he was still working to go to the moon. So it just shows you how much of a visionary the man really was.
The man had a very serious vision, yes, big time.
So fortunately, most of the good stuff we've got has come from the military.
Yeah.
CCD cameras, the cameras in our mobile phones today, the need to miniaturize and build stuff that can take the knocks and damage everyday life has come because it's something originally the armed forces needed, and once the technology is perfected and it becomes obsolete, it trickles down into the civilian market.
Yeah.
The mirrors, the technology to build the mirrors for the Hubble, ironically, came out of building mirrors for spy satellites.
Yes, the mods again. Yeah. I mean, it's horrible, but it did. We got some good results in the end. But necessity, the mother of invention. Unfortunately, through horrible means, but it's helped our technology grow and move on, and step by step.
Even disposable nappies came from when they had to put the Apollo landers down. The spacemen, the astronauts, had to invent nappies, disposable nappies for them, big ones, and eventually.
I'd like to thank them on behalf of myself. I'd like to thank them on behalf of myself and all of my children's bums. They're not particularly good for the environment, but yeah, I can see necessity. Yeah, necessity.
So we probably should go back to the old cloth ones again, maybe, or find.
I did. I used them on my first 2 kids, and then I realised I just couldn't do it anymore because life was too short.
Same here. Same.
Yeah.
Well, I'm going to tell you, folks, we're now at 45 minutes nearly.
All right.
Oh, my Lord.
I think it's time for me to go and have my glass of wine before it gets too late.
It's been great having you on, Johnny. We'd like to have you come back at some point.
Very interesting, John. It was lovely to hear about how it all works in schools and the interest and everything, and I can second that. Yeah.
Great to listen to you. Thank you so much.
Thank you all so much for having me on. I've really enjoyed it. It's been wonderful to be part of it tonight.
Once I get the show back from Philip, who's our audio production boffin, I'll send you a link through Skype so you can download the show, and I'll also send you the link to the show on YouTube.
That'd be great. Thank you very much.
And don't forget to put the links to the pictures.
Oh, don't worry, I won't forget. I'm going to simply say, and on that note, it's good night.
Good night.
Night. Thank you so much.
Yeah, thank you, everybody.
Lovely. Good night, guys. Thanks a lot.
Bye.
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 Night.
Good night, everyone. Clear skies.